Hello students, welcome back. We completed sections 1 and 2 and they're both about equations. Now let's study systems of inequalities. As a matter of fact, systems of linear inequalities only. We cannot start nonlinear inequalities. We're going to start doing that from lesson 9. Just a little bit of preview in lesson 8 and then the real bulk will begin from lesson 9. In any case, it's far away. So for now, let's consider linear inequalities first. And let's begin with the simplest case, systems of linear inequalities of single variable. The first case, we have two inequalities joined together through AND operation. AND operation corresponds to the intersection because both the first and the second proposition must be true. So x is greater than a and x is less than b means x is greater than a and less than b put together is a single double inequality. But oh, come on, x is greater than a and x is less than b. Here again, x is greater than a and less than b. Oh, if I read, they are the same. I just realized that. In any case, we end up with an interval, open interval a to b, because both inequalities are strict. And in this case, one of them becomes semi-inequality, so we have a bracket there, and vice versa. And finally here, both are semi-inequalities, so we have brackets for both. Deep down, the AND operation is basically the intersection. So both must be true. So keep those in your mind and let us solidify our understanding through actual problems. So we have these two. 4x minus 7 over 2 is less than or equal to 5 and 8 minus 3x over 4 is less than 3. Let's see. We went through a problem like this before in lesson 2, but that was for just a single expression only. Kind of like this. We went through this kind of problem in lesson 2. Remember this? Double inequality problem. Here, it's a little bit more general. One inequality with one expression and another inequality with different expression. And let's go ahead and solve each. It's not too bad. Both are easy. So 4x minus 7 is less than or equal to 10 if you flip over the denominator to the other side. And then flip this 7 to the other side. And then flip this 4 to the other side. Well, that's what I'm getting. And then if you want an interval expression, by the way, then it's going to be something like this. Yeah, okay, all right. That's another way to write the same thing. And that's all coming from blue. Now, how about the red inequality? Well, step 1 is denominator, so flipped over. 8 minus 3x is less than 12, is that right? Okay, flip this 3x to the other side. And then flip this 12 to the other side. And finally, divide by 3. Negative 4/3, and then like this. If you want an interval expression, it goes like this. So negative 4/3 to infinity, yeah, like this, yes. We don't have any bracket here this time. This is strict inequality, and that comes from red inequality. Now, how do I put together? Red and blue put together, so greater than -4/3 and less than or equal to 17/4. So you're gonna get this: greater than -4/3 and less than or equal to 17/4. Another way to write the same thing is -4/3 to 17/4, but the second is bracket because the right hand side is a semi-inequality. So you can do this kind of thing. Let's see, what did I do in my answer key here? Well, exactly the same thing here for blue. And then pretty much the same thing for red as well. Here, instead of moving 3x to the right, flip just 8 to the other side and get 4, and then divide it by -3, and that's how I flip the direction of the inequality. In any case, we get these blue and red, and then here we have a visualization. Blue corresponds to blue, red corresponds to red, and that intersection is purple. Do you see that? -infinity to 17/4 as blue, -4/3 to infinity, and then in between we have -4/3 to 17/4, that's purple. And you have to be careful about which endpoint is included and which is not. Here we have strict inequality, so -4/3 is not included. So here we have a parenthesis over here, yeah, to the left, and to the right we have bracket. You can do the same thing to the other problems as well, B and C. So stop the playback and do those on your own. You should be able to. They're both easy. Well, all done? Okay, let's go to B. Here we go. Step 1, the denominator, flip it over. Step 2, parentheses, no parentheses. Go to step 3, like terms, flip 5 to the other side, and final division. That's my positive integers, so less than 7/3, no problem there. Next, first the denominator, and then flip 9 to the other side, and finally divide by -2, which is negative, so I have to flip the direction of the inequality. And both are heading toward the same direction, less than or equal to 7/3, strictly less than 3/2, and visualization goes like this. 3/2, which is 1.5, and 7/3, which is 2.33 something, and we are talking about the intersection. So covered by both, so we go only up to 3/2. How about this? If you haven't done it already, then stop the playback and go ahead. All done? Well, not too bad. So, first inequality, flip the denominator, and then flip this 2, divide by 5, then x is less than 0. Now, how about the second inequality? Flip this denominator, -10, and then flip this 6, we get -16. Divide by -3, consequently, flip the direction of the inequality. And then what do we have? Less than 0 and greater than 16/3. Here's a visualization. Less than 0 here, greater than or equal to 16/3. No intersection. There's no region covered by both blue and red, no purple. So the solution set is an empty set. Excuse me, the empty set, not an empty set. There's only one and only one empty set, so it's the empty set. So that's how you can combine two or more inequalities together through AND operation. But that's not the only way. What if we use OR operation, in other words, union. That can happen, and we haven't seen examples like those yet, but in the second half of the course, when we start those when we have the higher degree nonlinear inequalities, in that case, we'll have to consider a lot of OR operations. So this can be considered as a preview of what's to come. Preview of something that will turn out to be very, very important actually. So if you have x is less than a or x is greater than b, then less than a, that's one interval, and then greater than b, that's another interval, and you can put those two together to union. So it's union, so if it is covered by any one or both, either way is okay. Here are some example problems, and then compare those with what we did here with AND operation. They're the very same, aren't they? Yes, this blue here and this red here, well, they're the same, and so on and so forth. Okay, how do you do this? The first problem. Well, stop the playback and go ahead. Or maybe not even that. I mean, we went through all those already, so let's go ahead. Here's blue solution, here's red solution. We did the very same thing in 3.2a. And then here's a visualization. We're looking for the union, so it's okay to be covered by anything. Covered by blue, or covered by red, or purple, covered by both. All okay. So we end up with entire real line, negative infinity to positive infinity. Next problem. Well, this thing corresponds to this one here. So algebraically, we have x is less than or equal to 7/3, or x is less than 3/2, and then if I put those two together, we get this. Less than 1.5 versus less than or equal to 2.333 that. And then this is OR operation, so either way it's okay, covered by red or covered by blue or both, all okay. So negative infinity to 7/3. Previously it was intersection, so we went up to 3/2, only those covered by both. But this time either A or B, both are okay. Finally this one. Well, algebraically it goes like this. Excuse me. It should be strict inequality. Sorry about that. Okay, I started with strict inequality here, so all these should be strictly less than 0. And then the second one, yeah, greater than or equal to 16/3. Graphically it goes like this. Negative infinity to 0. Or greater than or equal to 16/3. This is blue, and this one's red. And then blue corresponds to this interval, red corresponds to this interval, and they take the union, either A or B. You get that. Previously, we took the intersection, so covered by both, that was the empty set. But this time we have two separate intervals. So we can have empty set for and we can have everything for or. And then in general we have one or the other. Okay, that's how we can combine two or more inequalities together and form a system of linear inequalities.